This last lecture for Module 4, we're going to be discussing volume of prisms, volumes of cones, and volumes of pyramids, and also of spheres. If you take a look at what volume is there, it's just to measure the amount of space inside of an object. Another way to think of it is the number of cubic units in an object. Now if you look at this Rubik's Cube down here, you'll see that it has several cubic units in it, thinking of this as being 1 cubic unit. And if I ask you how many cubic units were in that Rubik's Cube, that'd be the same as asking the volume of that Rubik's Cube. And if you start counting, I think you'll notice there's 1, 2, etc. There'd be 9 cubic units on the top row, 9 in the middle, 9 on the bottom, for a total of 27 cubic units. So that's a good visual on what volume is. Now, the first thing we're going to talk about is volume of prisms. So, if we look at this first object here, this is called a pentagonal prism. And the reason is, think of that as a loaf of bread. If that was a loaf of bread and we were going to start slicing this, every cross section would look like a pentagon, a 5-sided figure. And since the cross sections are all exactly the same, then it's a prism. And that would be called a pentagonal prism or pentagonal based prism. The next one over would be a square based prism. This would be a rectangular based prism, and this is a triangular prism. Now the volume, to find the volume of prisms is very easy. You just simply use that formula right there. It's the area, that capital B is the area of the base. Okay, capital B stands for the area of the base. And then you take that area of the base and multiply it by the height of the object to find the volume. So to find the volume of this very first prism here, you would find, remember we said this has a base of a pentagon because every cross section is a pentagon. You'd find the area of that green pentagon, and then you'd take it times the height of that object right there. Now you might say that doesn't look like a height. Well, if you tipped that up and made it look like a skyscraper, that would make you understand that if it sat on its base, that definitely would be the height. So what if I ask you what the volume of this square based prism is? Well, let's say that it's 10 inches there and the side of the square is 4, which means the side of this square is 4. Well, all you do is find the area of this base. Well, that's 4 by 4. Remember, volume equals base times height. So the area of the base is 16, 4 times 4. Then you take it times this height, so you take it times 10 and you'd get 160, and I said those were in inches, so it'd be 160 cubic inches or 160 inches cubed. Hopefully that helps you out a little bit on volumes of prisms. Let's go back to the Rubik's Cube. If you take a look at that Rubik's Cube, I bet you agree that if we said that this top side was the base, this top face here is the base, well, that has an area of 9 square units. 3 times 3 is 9. And then it has a height of 3. So you'd take the area of the base, which is 9, times the 3, and you'd get 27 cubic units, just like we talked about earlier. Let's do something that's a little bit more complicated. Find the volume of this rectangular prism. Okay, well, this rectangular prism, we have to find the base on it. We're going to define this blue shaded area right here as the base of it, because every cross section would look like that rectangle. So remember, volume is capital B, which means the area of the base, times height. So the volume would be 2 times 5, which is 10, because that's the area of the base, times the height of 12, which gives us 120, and this would be in inches cubed. Now I'd probably be a better teacher if I said this. The volume is actually 10 units square, 10 inches squared times 12 inches. Right? This area over here is 10 inches squared, and this height is 12 inches. And when I take inches squared times inches, that's where the inches cubed or cubic inches comes from. Okay, let's talk about this trapezoidal prism. If you thought once again of that as a loaf of bread, I bet you'd agree that if we were to slice that over and over again, every slice would be a trapezoid. So how do you find the volume of a trapezoidal prism? Well, you use volume is area of the base times height. So the volume is, what is the area of that trapezoid? Well, remember it's base 1 plus base 2 divided by 2, all multiplied by the height of 7. So that's my big B right there. That's the area of my base. Now what do I have to do? I have to take that times this height right here of 15. So let's find out the area of big B, the area of the base. 6 plus 10 is 16 divided by 2 is 8. 8 times 7 is 56. So 56 inches squared is my capital B, my area of my base, and I still have to take that times 15 inches. And when I take 56 times 15, I believe I get 840, and inches squared times inches is inches cubed. So 840 cubic inches, or inches cubed, is the volume of that trapezoidal prism. How about a triangular prism like this chunk of cheese? We found the surface area of this cheese on our previous lecture. We're going to find the volume of this chunk of cheese in this particular lecture because we're dealing with volume. So let's find the volume. We know this is a triangular prism because if I were to slice this, like if I went down a half an inch and sliced this, I'd get a perfect triangle just like the one on the top of the chunk of cheese. So anyway, this is definitely a triangular prism. So to find the volumes of prisms, we have to take the area of the base times the height. Well, the area of the base on this, remember, to find the area of a triangle, you have to take the base times the height. So that's 10 times 12. And because it's a triangle, base times height divided by 2. We talked about y on our last lecture. So there's the area of my base, 10 times 12 divided by 2, and then we have to take that times the height of this object, and the height of this prism is 8 inches. So there we go. 10 times 12 is 120 divided by 2 is 60. 60 times 8 is 480. So this would be 480 cubic inches, or 480 inches cubed. Once again, don't do this. That would be wrong. That means 480 to the third power inches. That cubed has to go over here for inches cubed, which stands for cubic inches. Okay. If I ask you to find the volume of a cylinder, I bet you would agree all the cross sections would be a circle as we went if we were to do cross sections on this. So this is kind of like a prism. It's just a special type of prism because it's a circle. So what I was trying to say is, if we start doing, well, that's terrible drawing, sorry about that, but we'd have a bunch of circular cross sections if we started slicing this. So we still use V equals area of the base times height. The deal is on this is this entire top right here is my capital B, my area of my base. Well, what is the area of a circle? So my capital B is the area of a circle, which is pi r squared. And then we have to take that times the height. So that's why the volume of a cylinder is simply the area of a circle, pi r squared, times height. So the volume of this water heater here, we can figure that out. You might remember we found the surface area of this in our previous lecture. Let's find the volume of this. All we simply do here is take pi times the radius, and this tells us this water heater has a diameter of 2 feet. So it's 2 feet from here to here, which means it has a radius of 1 foot. So the radius is 1, and the height is, it tells us in the problem, the height is 5. From here to here is 5 feet, and my radius is 1 foot. So pi times radius squared is pi times 1 squared times height is 5. That gives us pi times 1 squared is 1 times 5 is 5. Pi times 5 is usually written as 5 pi. There's my exact volume. So the estimated volume, or I shouldn't say estimated, the approximate volume is 5 times pi, which is going to be somewhere around 15.7. So this has, this water heater contains approximately 5.7 cubic feet of water. Now, it'd be useful to use the information we learned back in Module 2, I believe it was, and we could convert cubic feet to gallons to find out how many gallons that held. That'd probably be more useful than cubic feet, but that's something we have learned how to do in the past. Okay, question for you. Let's say this cone and cylinder both had identical heights, so they were both so many inches high, exactly the same height. This was the same for both of them, and also the same radius. So the radius of this is equal to the radius of this. How many of those cones would fill up this soup can? Like if I filled that up with water and started pouring it in there, how many times would I have to pour it in there to fill it up? And if your guess is 3, you're correct. That's why when we find the volume of a cylinder, remember it's just pi r squared times h, but to find the volume of a cone, it's 1/3 pi r squared times h. So there we go. To find the volume of a cone, you just use the same formula as you did for the cylinder. Pi r squared times h, with one exception. It's 1/3 of that because of the fact it takes 3 cones to fill up a cylinder if they have identical radius and heights, or radii and heights. Okay, so let's find the volume of this cone. We're simply going to use the formula. Volume equals 1/3 pi r squared times height, which is 1/3 pi times the radius squared is 4 squared times the height is 5. Now, one thing you can do with that, you can just wait to multiply by 1/3. That's the same as dividing by 3. So if you want, you can just take your 4 squared, which is 16, times your height was 5, times pi, let's see, times pi, gives us that answer right there. There's our pi r squared times height. Now 1/3 of that, what we can do is just go divided by 3. And our answer is about 83.8 if we round. So approximately 83.8 centimeters cubed for that cone. Okay, for a volume of a pyramid, just like a cone, it comes to a peak, so you're going to take 1/3 of base times height. So on this particular pyramid right here, we're going to use the formula that we just learned. Volume is going to be 1/3 because it comes to a peak, the area of the base times the height. So that's going to be 1/3 times 36, because this has a square base down here of 6 times 6 times height of 15. And then we just use our calculator to figure that out for us. I think it comes out to be 183 into 36, 112. I'm pretty sure that's 180, but don't take my word on it. Okay, I want to make sure I get to the last 2 slides. So actually we just have this slide left. Find the volume of a globe if the radius of the globe is 9 inches. Well, you can't do that unless you know the formula for volume of a sphere. And here it is right here. It's 4/3 pi r cubed. By the way, I gave you a formula sheet for Module 4, and all these formulas are on the formula sheet. So all we're going to take is 4/3 times pi, whoops, I didn't need to put that in a parenthesis, but that's alright, times 9 cubed, because I said the globe has a radius of 9 inches. So the volume of this globe right here, we're going to let our calculator do the work. And it's important on scientific calculators, if you're going to start out with 4/3, put that in parentheses. 4 divided by 3, there's my 4/3. I'm going to take that times pi times 9 to the 3rd power. On this calculator I hit this button to go 9 to the 3rd power. And it's about 3053.6. 3053.6. And this globe had a radius of 9 inches, so the volume is inches cubed. Okay, you've seen all the lectures for Module 4 now. You should be ready to do your MyMathLab assignments and should feel ready to take your exam when that time comes around after doing your assignments. Thanks for watching. Bye.